So, bet you thought the dad jokes were over. I had a dream last night that I was swimming in a sea of orange pop. I told you I call it pop and not soda. Proudly. I was swimming in this sea of orange pop. And then I woke up and I realized it was just a fantasy. Okay. So in terms of what you're going to take notes on next, this is worksheet numbers 2 and number 3 for simple harmonic motion. And there are really just a couple concepts that you need to be aware of for these two worksheets. So behind me here, I have a blue mass. And this is a green spring that is attached to the mass. And this is like a table. And its friction is pretty much negligible. So this mass is free to oscillate back and forth as you like pull it and let it go. So just to give you an idea of what's going on here then, C, this would be like your equilibrium point. This is where this mass would be at rest if you just kind of leave it the way it is. Then we've got letter A, that is the maximum compression this is going to have. And letter E is the maximum stretch distance that it's going to have. So B and D then are just positions that are in between there. So the main thing I want to take a look at is I want to figure out at what positions we have like maximum velocity, maximum acceleration, maximum force, maximum displacement. Those four things are really what we want to take a look at here. And we can just kind of talk through them. I don't even have to put anything on the board. So let's just talk about displacement from the 0 point. Again, C is our 0 point. So which letters correspond to the positions where the displacement is the greatest? Anybody help? So which letters would correspond to the positions of this mass where the displacement is the greatest? Any guesses? Yeah, absolutely. A and E. Because if C is the 0 point, and A is the max compression, and E is the max stretch distance, then those 2 points would be the maximum displacement areas. C would be a displacement of 0. Okay, how about velocity? This is kind of an interesting one to think about. How fast is this mass going to be going at letter A? Zero. Because once the spring is completely compressed, this mass isn't going to be moving anymore. Letter A is kind of the position where the mass is turning around. Like if you throw a ball in the air, it momentarily comes to rest before traveling back downwards. Same thing with letter E. This would also be an area where your velocity is equal to 0. So you can see velocity and displacement are going to be exactly offset here. And like letter C, your displacement is 0, but as this mass is flying through letter C there, that's where its maximum velocity would be. So displacement and velocity are always going to be offset. Now in terms of acceleration and force, these two things are always going to be directly proportional. If you remember those two words used together in the first semester, directly proportional just means that when one grows, the other grows as well. So if you have a big force, you're going to have a big acceleration to go along with that force. So the positions at which your force is greatest would be A and E. Because when you're at A, this mass is really compressing that spring, giving a very, very large spring force. And at letter E, same thing, except it's really stretching that spring, which would also provide a large force on that spring. And so what you would have to do for worksheet number 2 and 3 is just kind of map out that relationship. But that's really all you need to do that. The only other thing I'll mention with regards to worksheets 2 and 3 is there's a part on the worksheet where instead of having a mass that's going back and forth horizontally, you've got one that's going up and down vertically. So if you're dealing with this, you got to make sure that you know a little bit about forces. So the force in this example is going to be the same as the force in this example. What I mean by that is that your force is greatest when you've got maximum compression and maximum expansion here. But the force you'd be dealing with in that case would be net force, because now you've got gravity down and you've got tension up. The difference between those two would then be your net force, and that value is largest when the mass is here and when the mass is here at maximum stretch. Because down here you've got a very large force of tension or spring force upwards, and you've got a smaller force of gravity, but when it's up here, now there's not as much tension. There's not as much spring force. So now gravity is larger than that. So your net force overall is going to be biggest here and there. And the same relationship exists between displacement, velocity, acceleration, and force as existed for this example. And that's really all you need for those two worksheets then.